Hello, everybody. Thank you for joining my project. We are going to talk about amazing technology for PV systems. So we call Virtual Center Power Conversion Unit for utility scale photovoltaic plants. This is Oscar Rosso, and the company founder of OS Tech Digital Energy. More than 10 years of professional work experience in the energy and industry sectors. In-depth knowledge in design, installation, assembly, startup, and commissioning testing of control and protection systems for electrical power plants, high voltage and medium voltage substation. Currently, at the OS Tech, I'm doing technical consulting on creation of turnkey solution in the PV, power distribution, and energy storage projects. So let's start with talking about OS Tech. OS Tech is a leading utility-scale solar project developer, delivering competitive, clean electricity to large energy buyers. Based in the US, OS Tech provides solar consulting and engineering assistance services for utility-scale solar PV systems, covering the feasibility studies, design, detailed plans, and specification for utility-scale solar PV projects. Okay, we are going to talk about the market opportunity and size. The electrical utility grid is rapidly changing with the increase of penetration of renewable energy resources such as solar PV, being the most noticeable change. By the end of 2018, global solar generation capacity was estimated at around 500 gigawatts. This includes over 100 gigawatt hour in 2018. Utility-scale solar installation account for 60% of solar capacity. Okay, before to talk about in detail the solution, I would like to introduce the two different technologies for PV inverters currently on the market. On the left side, we have the central inverter. On the right side of the presentation, we have the string inverter. The central inverter, the inverter essentially is the device that allows us to convert the DC power from the PV modules to the AC power to be connected to the grid and deliver it for any purpose. The central inverter units are physically much larger than string inverters, use longer wires, and convert more power per unit. In general, central units are rated at megawatts. The string inverters are smaller. Each unit converts less amount of power than a central inverter, and units are rated at kilowatts. Okay, so currently on the market, we have two different tendencies or topologies. One topology for power conversion units. On the left side, we have the central topology that relies on the central inverter technology, and we have on the right side here the string topology. Okay, the central topology relies the technology on the central inverter, so a big quantity of the PV array are connected to a unique big central inverter topology. And the other hand, the string topology relies on all the inverters are connected in a distributed fashion. So you will see like a one inverter per PV array. It's not a rule, but it's just in terms of, in general terms, we can say that one PV array has one string inverter. So the central inverter topology, as the same as the topology, has advantages and disadvantages. One of the main advantages of the central topology is the central inverters are less expensive than string inverters overall for large utility scale installation. Also, fewer inverters are required per site, and in general, overall lower installation cost is for central topology. The central inverter disadvantage, so in terms of reliability, much more power is lost if one inverter goes down. So if you see here the graphic, all these PV arrays are connected to one inverter. If the one inverter is shut down, all the power that can be produced for these PV modules are cut down because it doesn't have the inverter. So one disadvantage in terms of reliability. Also, the central inverter is a big machine and it's a complex machine that requires auxiliary service. So this is a disadvantage. It needs higher technical expertise for maintenance and installation. Also, you see, we have like a lot of modules and can be far away from the inverter, so we require long cables. Long cables means a higher installation cost for the cable, and also losses. We increase the losses when we increase the length of the cables. So on the other hand, we have the string topology. As well, with the string topology, we have some advantages and some disadvantages. One of the main advantages is in terms of reliability. The string inverter, less power is lost if inverter goes down. So as you see here in the graphic, when we lost one inverter, the power plant is going to lose the power produced for this PV array. All the other ones are going to be continue delivering power. So in terms of reliability, we increase is an advantage. Other thing about the inverters, this is a compact machine, like thinking about the plug and play and like a free maintenance. So we have less maintenance, less technical expertise required for maintenance installation, more granular energy optimization. However, we have also disadvantage. The main disadvantage of the string topology is overall higher installation costs, due also that additional electrical equipment must be added to the solution, like DC disconnector, panel boards, AC disconnector, etc. So nowadays, the market is very competitive. Customers require higher reliability, less cost. So what we are trying to achieve is this. We are showing you the solution. The virtual central power conversion unit solution combines the benefits of the central and string inverter topologies, improving the design of the PV power plant. It gives the customer an improvement of the reliability compared with the central inverter topology, and reduces the cost compared with the distributed topology. So the virtual central skid solution relies on the string inverter technology, in which string inverters are installed all together close to the step-up transformer in a central block fashion. Like you can see here in the graphic, all the inverters are tied together and very close to the step-up transformer. So the AC cable between the inverter and the transformer can be reduced a lot. So we have, what is the main purpose of this idea on this product is to combine the benefits of the two or the above existing topologies. So with this, what we are achieving right now with this solution is overall lower installation costs, because everything is going to be manufactured, assembled, tested on the factory in a skid. So we are trying to reduce the site cost that is huge here in the US. Also, we are tackling the higher reliability. Using inverters, we are improving the reliability compared with the central inverter. We are reducing the cables. If we reduce the cables, we are reducing losses, due that the distribution that we are using here is based on DC current and higher DC voltage. Less power is lost if one inverter goes down, less maintenance, less technical expertise required for maintenance and installation. And what we are trying to achieve is a plug and play pre-assembly solution. So all the inverters, as you see here in the graphic, all the inverters and the electrical equipment associated with the skid are going to be manufactured, assembly, all connected together, and shipped direct to the site, and the customer just need to connect to the grid. Okay, so we have also competitors, and the competition in the US is big. We have two big competitors. One is SMA, that is from Germany, and the other one is Sungrow, that is from China. They recently has released a virtual central power station topology for the US market using the similar concept that we are using. However, the solution that they are proposing is developed in Europe, and the other one is developed in China. So all the standards, they have to bring all the equipment here to the US, and has to be certified, UL certified. What we are trying to achieve is install everything in the US and use UL components, so we don't need external certification. So we are reducing the risk and also the time and price. Projections. Essentially, we have started this project in the beginning of 2020. We are planning to have like a unit sold around 70 for the first year. And in the year 5, we are planning to have like about 400 units sold. The unit price for each per each unit is $300,000. We are trying to achieve that 7 cents per watt for each unit. That is very good for the current market. So in general, for the first year, we are trying to achieve 21 million in gross sales and gross profit about $6 million. To do so, we have like a very strong team. As a financial director, we have Warren Buffett. As a project manager, we have Elon Musk. And a quality manager, we have Joseph Juran. In the electrical design, we have Oscar Rosso, and the prototype manager is Vicente Paz. A lot of experience in there. And we have our lead, Susan, it is a marketing lead. I would like to talk about the status and timeline. Numbers. So detail engineering right now is ready for construction, was released in April 2020, is PE stamp, and is ready for production. Prototype manufacturing is scheduled to be done by August 2020. Factory acceptance test to be done in September. And UL certification in October. As I told you, everything is use UL components, so we don't need like a external certification. We need just a verification for the first unit. And the official, we are planning to release an official launch by November 2020. So the only question I would like to ask you is, are you ready to get the sun and produce energy with us? If you are ready, we are ready to be your partners in the solar market. Thank you so much.